Hi guys, welcome. Um, this is my blockchain presentation, and in this presentation I will try to explain why I think blockchain it's a disruptive technology and why I think it will change the world. And I will go also a little bit more into the technology of Bitcoin in order to make you understand what bit of blockchain technology actually is. So it can be a little bit technical, but I will try it to explain it in layman's terms. So, like I said, I think blockchain is revolutionary, and I think it will change the world as we know it. It will have an impact on the society and economy and technology. So I think it will have the same impact like we had on internet, like in the beginning of 2000. We or we as the society became aware of the internet technology with browsers, and companies didn't understand. Well, why should I have a website and all this stuff, and this led to new players in the market and new technologies that were evolving from websites to search engines, and then we got a huge explosion with the mobile telephony, and that's all based on basically the success of internet technology. And I think we will have some such similar effect with blockchain technology as well. So it will definitely have an impact on society. For example, there will be decentralized autonomous organizations. So I will go into depth more about the term decentralized because that's really an essential word when you're talking about blockchain technology. So new companies will evolve. Um, and what's more important about this decentralized technology is that it will also have an impact on the economy and the technology. Of course, the technology will be different. New sorts of applications will be uh, developed, and you can see it more as a network layer that is being introduced into the world. But this network layer makes it possible to have agreements again amongst people, uh, from people to person. And in order to show you what the effect of this is, I will show you the next slides. But it will have a huge impact also on the economy. You can also see that the whole reason why, for example, Bitcoin has been invented, it's bringing the financial and the economy to all the people in the world. So the current situation where you have centralized systems, and at the end of the bottom of the pyramid you would have the folks, and even under under the pyramid there's a lot of exclusion of people which are not benefiting for the economy system because they're not in the right geography or the right whatever. With decentralized systems, it will be possible for everyone to participate. The only thing what is needed is an internet connection, and as we see it now, almost all people, also in developing countries, have an internet connection. So it's for sure it's interesting technology. Like I said, the term decentralized is very central in explaining blockchain technology. So, what in essence, what does blockchain technology do? Do It's providing a global database which is immutable, where you can store your agreements and data and make it available for everyone. So, in a centralized system, it would be that one uh, company or a government is responsible for having control over this data, maybe your data. In a distributed system, that's the generation we live in now within the internet. These centralized systems are spread out all over the world. So you got your Googles, your Facebook, your Airbnbs, but they are still regulated by centralized parties, meaning that you as a consumer don't have anything to say in how they do their policies or where you agree to, because there is not a real alternative now for example, for an Uber or an Airbnb. It's and with the decentralized system, there will be many possibilities and solutions, and it's up to you where you will choose your solution. So what does it mean? It means that there will be no more dependencies on traditional centralized institutes, no exclusion. Everybody is equal. The only thing what you need is a curious mind and the will to study open source documents and see what's going on. So that's for me. It's one of the things what makes me excited about blockchain technology. So if we go from past, present, future, uh, just to illustrate a little bit the difference between the centralized, decentralized, and the future systems. So in the past you would have your traditional newspapers, and in the present you will have those newspapers on internet technology where it's available all over the world. And with blockchain startups, it will be a million and one technologies, which makes it possible for everyone in the world to set up its own Facebook or Airbnb or whatever. And as you can also see, it's not mutual exclusive. So it doesn't mean that if you have, for example, your new coin for taxi services, that the Uber will stop exist, or even the traditional taxis will cease to exist. You will see all the traditional systems will still have a right to exist, and it's up to you what you choose to do it. For example, a lot of people are choosing Facebook, that's fine, but some people don't agree with their terms and conditions. For example, with the Facebook Messenger, where they can do all kinds of stuff with your private recorded or private messages, meaning that they use it for advertising campaigns. So if you don't agree to that, you don't need to do it. There are alternatives for that on blockchain startups as well. If you don't care, just continue to use Facebook. It's up to you. So this is the world I think we're going to see in the next couple of years. So now we will go a little bit more into the Bitcoin technology and why. So in Bitcoin, it's basically the first white paper or coin technology that actually mentions the term blockchain in its white paper. It's invented by Satoshi Nakamoto, and that's some anonymous person, and there's a lot of debate and discussions who that actually is. But the person who wrote this white paper about Bitcoin is basically a person who a lot of people believe uh, invented this technology as a protest of the banking systems. So in the years before 2008, we had a general banking crisis all over the world, where a lot of banks were speculating basically with money we had on our banks, and making the banks dependent on mortgages, and basically the mortgage and the financial system bursted, and the banks collapsed, and a lot of banks were saved by the governments, and the governments were the money from the governments is of course our money. That's the money of the taxpayers. So basically we were saving with our tax money the financial people who messed up the system basically, and still were a lot of those banks were getting large bonuses. And this is something that a lot of people didn't agree to, and they were like, I don't want to be dependent on a centralized banking system. I want to have my own financial system where I don't depend uh, on this technology or these centralized systems where a bank can speculate with my money, and basically I risk still the event that I'm losing all my money, and they can charge any interest rates they like to if they decide to change the interest rates. So the idea of having digital money on internet technology is not very new. In the beginning of the 90s, there was already an anarchist group called the cypherpunks, who already had a standard called Hashcash, and basically everything was around the PGP technology, and that was also around the idea that we need to use cryptography to make sure that Big Brother, meaning in this case the American government, cannot listen into our email conversations. And combined with this movement of internet money, Hashcash, the building blocks were already there for Bitcoin, but the official white paper for Bitcoin was written in 2008 by Satoshi Nakamoto. So in 2009, the actual first transaction on blockchain has been recorded, and I will tell you what it means. But if you go to blockchain.info, you can see all the transactions basically ever made within Bitcoin. And if you just type block number 1, you can see what the first transaction is. So what is Bitcoin? Essentially, it's a currency. You see a lot of people speculating with the coin, and that's basically why most people are involved in it now. But it's way much more than that. It's a network, it's a protocol, and it's a language. And basically, what's underneath it, it's the blockchain technology, and that will become very interesting, and that has been become very interesting with the second and third generations blockchain technology, what's coming up now. So what is the goal of Bitcoin? The goal is to provide Internet of Money, decentralized money, and that is available for everyone. Everyone on the internet can participate in this monetary system. Everybody can become a miner and join the network. Um, so that's in a nutshell the intro of Bitcoin. Let's go a little bit deeper. So in the centralized banking system, if I would transfer money from my account to my wife and to my children, I will go through a centralized system, and it's very easy for the centralized system to look into my account and then see if I'm transferring money to proper accounts. And if so, if I have enough money on my account, it's very easy for the bank to just deduct the money from my account, and then a couple of days later uh, transfer this money to the accounts where I say they need to be. So in this case, you see I transferred money from my account to my wife's and to my children, and it's all been transferred. And all the bookkeeping is kept in a ledger, and the ledger is in the centralized bank. So what happens in a decentralized system? If you want to get rid of the central player, you need to make sure that all the players, all the entities within your network, in this case, the entities are myself, my wife, my oldest daughter, and my youngest daughter, that all the entities in the system have a copy of this ledger. So if everybody has this ledger, then there is no need for a centralized system like the bank. This brings two problems if you introduce such a system, and those problems are captured as the Byzantine fault tolerance problem and the double spending problem. So there are other things, but those things are the main reasons why the Bitcoin and blockchain technology has become relevant. So the Byzantine fault tolerance problem, it's a very interesting mathematical problem, and there are a lot of people on the internet explaining a historical story with Byzantine generals trying to attack a village. But in essence, if all these ledgers have this information of transaction, in essence, I need to make sure, how do I know that the people are telling the truth? So how do I know that the transactions which are in these blocks contain correct transactions and they are not manipulated in some way? And I want to know that all the transactions are in a certain order, Because you can imagine if I say I have only 100 euros on my bank account and I'm spending 25, 25 and 50 in my first transaction, and it's not being processed in the correct way, that I can spend another 100 euros because the ledger has not been updated and the ledger doesn't know that I have already spent my 100 euros, or in this case of course bitcoins. So we need a way to know that all the transactions have been processed according to a certain order. And this order makes sure that double spending, like I just mentioned, doesn't occur. So in order to solve these two problems, the Byzantine fault tolerance and the double spending problem, the white paper talks about a consensus algorithm. And this consensus algorithm is based on cryptography. So what they basically say is that all these blocks contain transactions, and the transactions are chained, and the blocks are chained in a ledger. So the complete set of transactions and blocks, that is the ledger. And they say the longest block or the longest ledger means that the most computation has been done in order to achieve this, and the longest chain is the truth. That's the correct ledger. And I will explain later on how this computational work works and what is in this ledger. But the consensus is basically that the longest chain of blocks corrects the most computational work. So it means that this ledger is the correct ledger. So then you would say, okay, if people are creating this ledger, why do they not put in false information? So coming back to this Byzantine fault tolerance problem, why should they not say, okay, I'm receiving 1 million Bitcoin? And that's because it's not possible to do that, because the people who are responsible for putting these blocks on the chain, the miners, are not incentivized to put false information on the block. Meaning, if you want to put information on the blockchain, you would have to spend a lot of compute power to make even a slight chance to win this compute power block. And if you win this block, then you would get a reward. So meaning all the people who are mining are incentivized to tell the truth. If they're not telling the truth, so with this cryptographic puzzle, we can prove that you have put false information on this blockchain, then you will not get this reward. So it doesn't make sense for you to put false information on this blockchain. And you would know for sure that if you're telling not the truth, there are way more people who are telling the truth, because more people are incentivized to tell the truth about the blockchain. So how can you prove that you are telling the truth? In order to do that, you have to solve a cryptographic puzzle. Because this cryptographic puzzle basically says, if you solve that, you would need to have a lot of compute power to solve this cryptographic puzzle. In order to understand this cryptography a little bit, we need to go a little bit more into crypto knowledge. And in order to understand that, you need to know what a hash, a fingerprint, and an asymmetric key is. So I'm just changing my mind. You don't need to know what an asymmetric key is. So, but be assured that we are using all asymmetric keys, because all this technology is based on PGP technology, PGP encryption. With PGP encryption, there are basically two things what you can do. You can do more things, but you can encrypt data, and you can fingerprint data, making sure that you are the signer of a piece of data. So how does this work? When you create a PGP, you would create a public and a private key pair, and that makes it also part of this asymmetric technology. With this private and public key pair, if you're trying to encrypt a piece of data, so for example, I like I would like you to send me information that has been encrypted, and I can be the only one able to read your encrypted data. I would give you my public key. You would encrypt your data with the public key, and this encrypted data is being sent to me. And with my asymmetric private key, I can decrypt the encrypted data you have sent me. So you can see that only people with the private key are able to decrypt the data which is encrypted with the public key. So you can also do this the other way around. I can say, I like to prove that I am the sender of this data, and I can be the only sender of this data because I'm providing you a signature. So what then happens is, I have a piece of data, for example, all my transactions. These transactions are being signed with the private key, and I can be the only one who signs this because I am the owner of this private key. And then it would generate a signature. If I send to you the signature, the data with the transactions in combination with my public key, you are able to execute the verify method, and the verify method takes three parameters, called the message, signature, and public key, and then you can see if the data you have got is signed by a person who is the owner of this private key. So this is being used when you are sending transactions on the ledger for blockchain, or for Bitcoin in this case. Then there is the concept of hashing, and don't worry, I will combine these two together in a actual transaction later on. But hashing is very important, because what you do with hashing is basically giving a unique key for a piece of data. So this data is Chris sending data to Lotte for 20 Bitcoin, and I will mine this, and this piece of data will generate a unique hash key. This hash key, what's being used in Bitcoin, is a SHA-256 hash algorithm. Basically, what you need to know that it's a cryptographic algorithm that's a one-way hash, meaning this is so unique for this piece of data, but you cannot ever deduct what computation you need to do in order to get this back. And this piece of data is always unique to this hash key. If you see, if I just change the bit to a 1, you would see that the complete hash has changed. And this is true for all pieces of data. So a piece of data could be, for example, a piece of music, but it can also be a complete 4 gigabyte movie which you downloaded legally, hopefully. It will, if you put a SHA-256 hash, it will always generate a hash of this length. So let's go back to the presentation. So what you need to know in Bitcoin, encryption is not being used. Signing is being used, but it's being used for signing the transactions. So what happens if you make a transaction in Bitcoin? So I'm creating this transaction, and I'm creating another one. And this is being hashed. So this hash is unique to this piece of data. This piece of data is being signed with my private key, and the private key is a key which is stored in my wallet. And I will send this message, so the data of the transactions, the signature which is generated with my private key, and I will send the public key to the mempool, and I will tell you what that later is, and then it will be verified if this is really me. So if you can see, if you sign a traditional check for a bank, your signature is always the same and the numbers are the same, only the amounts will probably be different. When you do a signature with a Bitcoin transaction, it's actually much safer because, as you can see, every time I create something in a transaction, I get a different hash key. And this hash key is being signed with my private key. So it's way more secure because every time I would have a different signature, but every time you can verify if the message is really signed by me by calling the verify message. So we have all these transactions, and these transactions are being put in a block. So hence later on you will have the chain of blocks called the blockchain. But what is in a block? So in a block you have a header, and the header is very important. First of all blocks got sequential numbers. So in my presentation you see I got block 1, 2, 3, and it contains a version. This version is important for later on if you are changing the protocol and you need to know which version you are using. Then you see a field in the header which is referring to the previous block hash. And if you remember what a hash is, it's a unique number of this complete block, but it's referencing to the previous block. So this makes it possible to chain the blocks. If you can see in block 1 to 4, you see there is also a reference to the previous block hash. And that's basically a hash of all this data. Then you got something that's called the Merkle root. And a Merkle root is basically a hash of all the transaction hashes. So it's, if you have, like, for example, 10 transactions, you would have in some kind of tree form, you would deduct all those transactions, and all these transactions will be hashed into a unique hash called the Merkle root. If you change anything within with one of those transactions, the complete hash will be changed for the Merkle root. So the Merkle root will know that one of the transactions has been manipulated. All blocks will also have a time field, and the last two blocks, difficulty and nonce, are being used for the mining, and that's something I will tell on later on in my presentation. So if you have all these pieces of information in the header, those are being converted into hexadecimals, and then some kind of conversion will take place. It's called Indian reverse. All these pieces of information are concatenated, so put right after each other, and then of this complete piece of hexadecimal information, that will be SHA-256 hashed. And this hash is basically what will be stored in the previous block hash of the next block. So to demonstrate you how it looks, this is a simple demo app that has been written by a guy, and it's pretty cool. So here you see I have mined my first transaction, and this nonce is a random number that has been generated by the protocol. So I will generate my second transaction, 10 Bitcoin. I will mine this information, and you see this piece of information has a unique hash with the nonce and this data together. It's generating this hash block. As you can see, this hash from the previous block is being put here as a previous block hash. So if I create another transaction, is 10 Bitcoin. I will mine this information. I have a complete chain of transactions which are in my block. If, for example, I would change something within this block, that will make these blocks invalid. So as you might remember, one of the consensus rules is that the longest block contains the truth. And as you can see, this is a cryptographic truth, because if someone manipulates something in this transaction block, it will change the hash and the blocks will all be broken which are following from this manipulation. So if I would put it back, I don't remember what it was, this one, you would see it has corrected itself. And of course, this is the same with this thing. If I changed it, it will make this complete chain invalid. So, putting it back. So if you go to blockchain.info, you will see all the transactions ever being mined. So that's pretty cool to have a look. So if we follow a transaction, you would see that, for example, this is my wallet, and a wallet is basically a piece of software which contains only my private keys. And I will not go into depth on how you can store those keys. There are several technologies for that, but basically, Bitcoin doesn't store your coins into my wallet. It's a collection of input and output transactions which are gathered in this blockchain. So in this blockchain, my wallet knows that I have this public IP address, and public Bitcoin address, and based on this public Bitcoin address, it can see in the ledger what all my input transactions and all my output transactions are. So my input transactions is of course all the Bitcoin I have ever received by mining or by buying it or by going to an exchange, and you can also see all the transactions I've made spending money for my public key, and that's linked to my private key, of course. So the sum. So in the ledger I have, for example, 100 bitcoins input and 75 bitcoins output. Then I would have 25 bitcoins in my wallet. So what does a wallet do? It signs the transactions, it validates it, and then afterwards, if you are sending this transaction, it will transmit those transactions into a thing called the UTXO or mempool. And UTXO is basically a pool of unspent transactions that still need to be mined. Then there is a collection, or all the miners in the world are basically listening to this mempool, and in the protocol of bitcoins it's being said that every 10 minutes there will be a block mined. So this block I mentioned earlier will be added to this blockchain ledger. So in order to make sure that the 10 minutes are being are achieved, the blockchain protocol has two tools in order to get this. So it can manipulate the difficulty, and it can put a nonce in there. And I will go later on into mining. What does it mean and how does this mining work? But basically every 10 minutes the cryptographic puzzle is being solved, and one of the miners, the miner who's the quickest to solve this, will be awarded with blockchain reward and a fee. And then this miner can add this block to the blockchain. So in this case, it has one. This miner has won the block, and it can add this block to the blockchain, and it is awarded with blockchain reward and a fee. So this cryptographic puzzle, what it is, I will tell you in the next slide. But so I like to show you the first transaction, what I showed you here. So to reiterate, I got a wallet from Mr. Henk, a wallet from Mr. Chris. Wallet Hank has one transaction, I got three transactions. I sign, validate, and transmit those transactions into the mempool. Then there are miners, and those miners are often part of a mining pool, and those are all mining and using these transactions. And basically, what they do is they solve a puzzle with these transactions, and if they win this puzzle, they can create a block and add it to the blockchain. And all the ledgers here are synchronizing the blockchain. So they have the latest state of the ledger. And like I said, the ledger is the ledger with the longest chain of blocks. So what is this cryptographic puzzle? Bitcoin is based on a consensus algorithm that uses proof of work, and the proof of work has a relation with spending a lot of compute power. So what do miners do? They secure the network, and they have a consensus which miner is allowed to add the block with transactions. And like I said, the winner of this cryptographic puzzle gets a transaction fee and a block reward. What is this cryptographic puzzle? Like I said, here we got a difficulty and a nonce. And in order to achieve this 10 minutes per block achievement, Bitcoin needs to be able to adjust the difficulty. You can imagine if there are not a lot of miners, then it's pretty easy that one miner will win. If there are more miners, it will be more complicated. So the more miners there are, the puzzle will be solved quicker. So in order to regulate this 10-minute boundary, Bitcoin makes it more. The more miners there are, the difficult. So the more miners there are on the mining pools, Bitcoin makes it more difficult to solve this cryptographic puzzle. And it does that because it wants to withhold this 10-minute boundary. So what does this puzzle do? Basically, all the miners are just guessing a random number, and the random number is the nonce, and the nonce is something that is defined in the block. But of course, the miners don't know what this number is. So, what is this nonce? So they will never, or it is highly unlikely that they will ever correctly guess what the nonce is. But what they say is that oh, that the difficulty is set to some kind of number, right? And this number is it's a very long hash number. The the hash number is basically like a number in the binary system where we could have a number from 0 to 10 billion, being 0 the lowest and 10 billion the highest number. In this SHA-256 hash, the lowest number is of course all zeros, and the highest numbers will be FFFFF, all Fs, because it's a hexadecimal system or numbering. So you can imagine that the more zeros there are, the lower the target is, and the lower the target is, the probability that you are guessing the correct nonce, so a nonce which is within the boundaries of this piece, is much more improbable than if the target or the difficulty has a number with less zeros, meaning there is a larger range of possible nonces. And this difficulty target is basically when you are doing a hash and you want to become the winner of this block, you are guessing a hash which is within the range of this difficulty. And the hash, what is being calculated is the hash of the block. So I just showed you all the transactions and in combination with a random number, the nonce. That's the hash, and you have to see if this hash is within this target. If you are guessing that, you have won the block, and you should be of course, the first one to guess this number. Uh, there are other alternatives to this. One of the main reasons why not a lot of people are liking this proof of work algorithm is that it's using a lot of compute power. So people say there is about 1% of the total world's consumption of energy is based on proof of work on mining of coins. So that's quite a lot of energy, and basically what they're all doing is solving a puzzle, and once this puzzle has been solved, then all the computational work of all the other miners is being neglected, and we're going to the next block. And so this miner wins, it's being broadcasted on the ledger. Everybody knows, okay, it's time to block to mine a new block, and all the miners will start with mining a new block, and trying, of course, to be the first one to solve this block. So alternatives are, for what I know now, is proof of stake and proof of importance, but there will be many more to come, and all the protocols will have its benefits and its non-benefits. So mining, what does it pay? Uh, One of the things which are stated in the protocol as well is that every 210,000 blocks, and that's about 4 years, because a block time it's about equal to 10 minutes. You can calculate it back that 210,000 blocks are 4 years. That the reward, the block reward, will be halved. So if you go to blockchain.info and you type in the first block, you will see that the first block generated 50 Bitcoin. So let's go to blockchain.info and I type here number 1. You see that this is block number 1, and here the block reward is 50 Bitcoin. And at that time, of course, Bitcoin didn't have the price that it would have now, because now it would be 10,000, so it would 50,000, would be 500,000 euros. So that's quite a lot. So you can see about 4 years later it's 25, and this is what we have now. And 4 years later it will be 12.5 Bitcoin. So you will know that it will never reach a block reward of 0, but the block rewards will be less and less and less. And basically what makes it still attractive for people to mine these blocks is that you also have the concept of a fee. So if all the rewards are so low that it's not interesting for you to mine anymore in Bitcoin, then you will still earn your money with fees. You will have several generations of Bitcoin miners. First generation was because there were not a lot of competition. You could just use your PC. Then more and more miners came. You need to have faster computational power if you would stand a chance to win or be the fastest in calculating this block. And then a lot of people started using GPU. So they were putting the calculation of guessing this nonce and hashing this information with the SHA-256 algorithm. They use the GPU, and then the generation afterward is using ASIC miners, and basically those are chips with a lot of cooling, and those chips are specifically built to do this SHA-256 calculation. You cannot do anything else with them. So they're really silly machines, but they are incredibly fast. So this one, for example, can do about 14 million calculations, SHA-256 hash calculations in a second. So another thing what I like to say that Bitcoin has actual value to create because if you have money, for example, it's basically only worth, the paper money is only worth because the government says it has a certain value. But if you would have the money and just as a piece of printed paper, it's just worth the paper and the ink which is being used, and that's not a lot. If you would like to generate a Bitcoin at the moment, in February of 2018, it will cost you about 1,500 euro electricity costs to mine one Bitcoin. So that's a lot of computational power and a lot of work just to create one Bitcoin. Of course, a lot of people are moving their miners to countries where electricity is a lot cheaper, but still, it's a lot of time and effort to generate one Bitcoin. So that was a lot of information about Bitcoin into depth, and to be honest, I know Bitcoin for a long while, and I think I heard first of it from 2011 or 2010 or something like that, and I wasn't really interested in it because I was like, that's nerd money. It's funny to play, but I don't see a real future in it. Didn't spend any time in blockchain or reading the white paper or the yellow paper because yeah, I was like, cool stuff, but I didn't find it revolutionary at the moment, and that's probably because I was also ignorant in not knowing what was going on, or I didn't hear good speakers about it. But then, for me personally, about 2 years ago, I heard of Ethereum, and basically that made me very enthusiastic about blockchain technology because the way I see Ethereum, that's like Bitcoin 2.0. So what happened? You see this guy on the right in the bottom, that's Vitalik Buterin, and he's generally considered as to be the one of the founding fathers of Ethereum. He was already busy with Bitcoin, and he was use of the or he was part of the Bitcoin core group, which is the who are the developers of Bitcoin and making Bitcoin secure and safe and better. And he had the idea to extend the script language that Bitcoin had. Bitcoin has a script language called Script, uh, and he wanted to evolve the script language because script from Bitcoin is very simple. It's just based around computational or computations about sending money from and to wallets, and that's basically what Bitcoin does. But he wanted to make a Turing complete language on top of Bitcoin, so you can create your own contracts using a complete programming language. So basically, he said the current generation of Bitcoin language script is not Turing complete. You can only do simple things. You cannot create your own intelligence and logic. And the Bitcoin community basically rejected his proposal, and so and that's why he basically set up his own uh, copy of Bitcoin, and he created Ethereum. And with Ethereum, you can do just more than just create Internet of Money, because you can create your own contracts. You can create your own logic using smart contracts. So Bitcoin only stores transactions, and but when you use Ethereum, you can store anything. Sky is the limit. Uh, and basically, what Ethereum is doing is it's using Bitcoin's blockchain technology, but it gives you the possibility to create on top of Ethereum also your own contracts. and I will show you later on how it looks like. It uses a technology called EVM. Like in the Java language, you can have a virtual machine which interprets bytecode. And basically, what you would do is you would compile uh, your programming language into bytecode, which is being used on the EVM. And the EVM is basically being run on all the nodes within the Ethereum network. So all the nodes in the Ethereum network would have a copy of your contract, and making it also very secure, of course. Currently, I only know that Ethereum is using Solidity, and Solidity is some kind of JavaScript language that makes it possible to create in a simple way a contract on the Ethereum network. So you have a Solidity programming language. You would compile it into EVM bytecode, and then you would publish it on the Ethereum network. Bringing this technology with the Turing complete language into Ethereum also brings dangers into the play, because if you know a little bit programming, then you would know what a loop is. But the loop is basically something you can do iterations in your language, and when you do iterations, you can also write logic that is referring to a begin state of the iteration, making the iteration an infinite loop. So if you would call something within the contract, it would be possible to write a piece of code that would basically drain the complete network, because all the computational power on the nodes is being used for running the piece of contract that you have written. So in order to prevent this behavior, the concept of gas is being introduced in Ethereum. And what gas basically does is every transaction you do within calling some piece of code within your contract is got gassed. So if you would have an infinite loop, you would basically drain your wallet with gas. And in a transaction, you would usually say, I would like to have a maximum of gas usage, so that not all your wallet is being drained. So for you as a programmer, it's interesting to write code that's very simple and smart and elegant, so you don't use a lot of gas. The introduction of Ethereum had something crazy that last year went on. Is it introduced the concept of ICOs, so that stands for initial coin offerings. So when you create a contract on Ethereum, it's very easy to create a new coin and say, okay, this coin is worth an X amount of Ethereum, or it's pegged against the euro. You can create any ID you would have and publish it as a contract on the blockchain of Ethereum. And what's cool about that is that a lot of smart people and creative people, so I consider myself not smart but a creative person, but a lot of people in the world had great ideas, wrote newspapers last year, and published an ICO, smart contracts, that people could invest in. And what happened is that a lot of people made the market boom, and they became aware of the concept of Ethereum and smart contracts, and a lot of people saw how easy it was to get funding for a great idea, because basically when people are participating in an ICO, they're putting money or Ethereum and they've deposited to a smart contract, and the owner of the smart contract is the owner of all the money that has been put in this space. So that brings a world of possibilities, but it also brings a world of concern. And that what's also what happened last year is some people are being scammed. So this is a new world. It's not regulated. A lot of things are happening, and because of this non-regulations, prices are being skyrocketed, but it's also being put down very easily because a lot of people are fearful of basically stuff they don't understand. So one of the things what happened last year is there was a game introduced on Ethereum called Crypto Kitties or Script Kitties or something like that. Basically, what happened is you can buy or create an avatar and modify it or adopt it, and it's a very simple game, but it was very popular on the Ethernet, the blockchain. And basically, what happened is because a lot of people were buying these silly things, the network was clogged. So you could see that also the technology in this space is very new. It's not very scalable, and rest assured that there are a lot of smart people. People like Vitalik are working on this problem to solve it, to solve the scalability problems and the problems that are arising in this new technology. But the concept of a blockchain, it's very strong, and I see great future in this. And especially when you can write your own logic and ID and publish this and on this on blockchain technology. So you would have your creativity and your ID, and you can publish it very easily with simple technology, and the underlying network technology under it, the nodes and the blockchain technology, which assures that your contract is there, it's immutable, and everything that is being done on your contract, like adding a user or anything that change a state of your contract, that's being recorded as a transaction, and that's all being persisted there. It's also finitive. When you do something on this chain, it cannot be changed anymore, and that's very strong. That's a very strong concept. So if you go to a thing called CoinMarketCap, and that's basically a tool what a lot of investors are using. The, the pop-up you saw was one of the guys I'm following online. I love this guy. So if you go to CoinMarketCap, you see basically what the market capital is and which are the biggest coins and what's growing and what's the price. The prices you see here are basically an average of all the trading sites around. So in the trading sites, it's basically a matter of supply and demand, right? So if on Binance the supply and demand for Bitcoin is greater than on KuCoin, for example, which is another trading site, then the price of Bitcoin on Binance will be higher than on KuCoin, but the average of all these prices is being calculated here. So this is the average market price for one Bitcoin in euros. When you go to this site, you see there is a distinction between coins and tokens, and that's something that people need to know. So when we are talking about coins, we are talking about a platform, a technology like Bitcoin, Ethereum, Neo, Cardano. Those are all platforms, meaning they have their own network, they have their own protocol, they have their own staking or the proof of work consensus algorithm. It's all in there. On these platforms, you can have some of these platforms support the concept of creating a smart contract. And a smart contract is also being represented as a token. So if I go to coins, here you see all the platforms. And if I go to tokens, you can see the biggest tokens at the moment. And the biggest tokens at the moment, you can also see which platform they're using to run on. And by now you can see that the largest platforms at the moment are on Ethereum, but rest assured there are other platforms coming up as well. So interesting stuff. So sometimes you also hear about ERC20 tokens, and basically what you need to know that ERC20 tokens are based on Ethereum, but they implement a specific interface with functions and events, and those if you create a contract that implements this interface, you know that a wallet can communicate with it because a wallet understands these interfaces. Of course, you can override these functions and or you should override this function and implement your own logic with it. When you go to Solidity, a smart contract code would look something like contract, some contract, and then between the accolades you would have your code. And with an ERC20 token, you would have this contract, and you would have this is, and then you would say it will implement this interface. Okay, yeah, I already mentioned this, I think. So if you would have your contract on Ethereum, it would consist, for example, a variable called balance. If you would do execute the get balance method, it would only get the balance. It is not changing the state of the contract, so no transaction is being recorded. It will not be recorded as a transaction on the blockchain. But if you would say add balance and you would add like 10 euros or 10 any token to your balance, then it is considered to be a transaction because you are changing one of the properties in your contract, and that's being recorded as a transaction. So a couple of alternatives I would like to mention. So there's Lisk and Neo, and what I consider the generation 3 of Bitcoin is the EOS and Cardano. Neo is being considered like the Ethereum of China. It handles way more transactions than Ethereum at the moment, and there's a lot of activity going on. So if currently it's like end of February 2018, I would for sure put my eggs on this basket. But oh yeah, I should say this is not financial advice, but anyway, I believe in this project. Cardano and EOS are generally considered as things for the next generation, and that's basically because they're so huge in transforming the technology. So concepts are like interchain blockchain, so you can connect your other blockchains to each other. Concept of having multiple proof of works or proof of stakes or consensus algorithms. Those are being all done in Cardano and EOS, and something to really have a look at in the future. So I've discussed Bitcoin into depth, a little bit quicker about Ethereum, but Ethereum is basically what made me enthusiastic about blockchain technology. And then I would like to go into depth, where is blockchain good for? So in IT there is this thing called the golden hammer, and that's basically an anti-pattern. I mean, an anti-pattern is something that a lot of people are using. For example, the golden hammer is you got some kind of solution, and this solution works for you, and then every problem you see or you encounter in your life you would use the same solution for, because it works for you. And that's basically not a good pattern, because every problem has its own solution, and some solutions are better than others, and of course you should always see if there are other people who already solved this problem. Basically, your solution doesn't mean that if it works for you, that it will solve all the problems. And that's also with blockchain. Blockchain technology is good for a certain scenarios, but you cannot use it in every scenario. So it's good for having provenance. So if you want to show where some goods are coming from, and you want to track these goods, it's very cool to combine this technology, for example, with IoT technology, with sensors, and you can see where some goods have come from. If you want to be sure, like if your biological olives are coming from farmer A from Colombia or whatever, then you can have this information registered on the blockchain, and you know for sure that nobody can put this information on this blockchain than this sensor, which is now in your living room. I'm just saying something. It's transparent. Everything is open. You can see it in on the ledger. But also always ask yourselves, why should I not use a regular database? Why should I have this decentralized solution? Because if I trust my provider, why not let him just persist it in a simple database? That's much cheaper and much simpler, and that's already available. I don't need to introduce this blockchain technology for this. If you want to achieve consensus, it's also very interesting because also then you don't want to be dependent on a central authority. Consensus uh, should be driven by incentives because you want that people are telling the truth, and in order to tell them the truth, they need to be incentivized. Um, a good example is that you don't want a middleman anymore. So that's a very good scenario. If you want to get rid of your middleman because it's expensive and slow, or you have information silos, you should. Blockchain is a very good scenario to use for. So I always use the example I hear on the internet as well of Western Union. A lot of people are working very hard to send money to their families, and Western Union is charging like 15% of this transaction to deliver this money to the recipients. And then on the recipient side, you know that those offices are often being checked by robbers. So you don't even know if your mother or whoever is on the other side of your recipient side is getting this money safely. And for example, if you would like to make sure that the recipient is using this money what you agreed on, you don't have any control over that as well. So if, for example, you make me a promise that if I give you money and you want to use it for paying your rent, once it's being transferred with Western Union to the post office in the country where you are at, you pick up the money. I don't have any control over what will happen with this money. So it's very secure. When you have this scenario where you would like to have your information stored all over the world globally and it's immutable, then blockchain is for sure very good because it's not one central system you can attack. You need to attack the whole world, and trust me, that's way harder. Because it's available or being persisted by nodes and by ledgers all over the world, it's also high available because your ledger or a copy of the ledger always resides somewhere in the world. And a blockchain is good for having finality. So, like I said earlier, all your contract is immutable, and everything which changes the state of your contract is being recorded as a transaction. So it's very trackable of what's being done. Uh, Another thing which is a danger is that because of the nature of this technology, that when you write some code or you publish some contract on the chain, and it's immutable, if your contract contains an error or a bug, it can be exploited. So and basically what you do is throwing your or making your coin or solution completely worthless, because if it contains a bug as big as we had in the with the DAO hack in with Ethereum, if you create such a failure, then basically what can happen is that all the money you have collected with the ICO can be robbed, and that's not a good feeling that people have, of course. So when you publish something, please make sure you're making use of good programmers and it's being tested very carefully before you publish it on the main Ethereum network. So some use cases, non-finance, because finance is pretty obvious what you can do with it. But when you go to manufacturing, it's very interesting for origin tracking, real-time data, certification and documentation. Within the healthcare, it's very interesting to send information from one entity to the other, from your hospital to your a practitioner or whatever. It's you are in control. And for example, when you have want to have a total control of the data, and when you say I'm transferring this data, you can also say that the data afterwards will be thrown away. So customer loyalty programs is very interesting, because you can have coins and monetize the saved stamps or saved tokens for when people are purchasing stuff, and make it monetizable, so that people can actually buy stuff with your coins. And also for real estate, very interesting in developing countries where there is no trust in governments or other governmental institutions. For example, there could be waiting lists, and we don't trust the 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 officers who are responsible for these waiting lists, because they can put their own family people in front of the line. And basically, when you use blockchain technology, that's not possible, because this contract is immutable. You can make in your contract for sure that all the waiters are being handled in the right order. Insurance, of course, you can have the scenario where you have cars with sensors, and good drivers will be rewarded with a lower premium, and terrible drivers will be paying a higher premium in insurance, so making the world a lot more honest. Um, and of course, in advertising and accountancy, it's all very interesting to use blockchain technology. For example, in advertising, you as a company would like to know what people are actually consuming and listening to, and you want to have impact on that. You can make a contract and actually see that people are watching your content, and the people who are watching are being gathered with personalization data. So you have a targeted audience. So with this target audience, for example, you can make a player and say, okay, people who are in my target audience are actually watching this. I am rewarding them with some kind of token. So basically, you are paying them as an advertiser to watch certain content, and that's possible, and it's controllable, because you have recorded everything on the blockchain. So next to the technology I've talked about Bitcoin and about Ethereum and about smart contracts, those are all things which are happening on the public segment. But of course, a lot of stuff is going on enterprises as well. And basically, what you would have there on enterprise level, there's much more a need for permissive blockchain solutions. So basically, those are contracts which are more regulated and have, for example, more traditional standards like identity access management and usage of HSMs and certificates. So basically, you would have contracts which are more strict and have a less permissive solution. But of course, you can also have the solution that a lot of companies would like to interact with each other, and they would make enclaves or trusted situations, like I'm trusting company A and B, and together we are an enclave, but they can all use their own blockchain solutions. So within Azure, we got a blockchain as a service, which makes it as a developer very easy to get started with blockchain technology. But we also got frameworks, and the frameworks are basically uh, um frameworks for creating your solutions often on an enterprise smart contract based solutions, and you can make use of components within the Azure cloud services framework. But the frameworks are built in such a way that they don't tie you into using a certain technology. Everything, every component that being made available is being made available for you to choose any solution that you like. So for example, if you would like to use on the lowest level of network, you would like to use the Hyperledger or Stratus or multi-chain or Quorum, uh, you are allowed to do that. And if you like to communicate with another solution, which is based on Ethereum, for example, you're allowed to do that as well. So that's on a network layer, but we got also like a project called Bletchley, which is not available at the moment yet, but that will make the generation of smart contracts easy, and you can use the PaaS solutions from Azure within your smart contract with that. So that's all very interesting technology. So I end this presentation. It's a lot of talk and information, but usually I would end this presentation with a lab. And in this lab I would I have a Docker file which talks more about generating private and public keys and encrypting some stuff and generating a fingerprint and checking if this information is really from you. This is more the basics of the crypto stuff. Then we would go to create an actual smart contract, and the actual smart contract is using MetaMask. It's using the Truffle framework, and all the contracts and stuff. It's available on this GitHub URL. So it's github.com, my name, and then Blockchain Lab. So hope you guys enjoyed it. It's exactly 1 hour, so it's a lot of information. But this is my blockchain story, so I hope you guys liked it. Let's go to this thing. Stop. Oh, it's more than an hour.